Welcome to this latest video. In this video we're going to look at database concepts. We're going to build from the idea of not knowing much about databases, fill in key terminology, look at flat file databases and what are their limitations around having a single entity in a flat file and what happens if you have multiple entities, making use of relational database to solve some of these problems, and then looking at some of the problems that this could throw up, such as many-to-many relationships. Great, let's get to it. Welcome to this lesson. In this lesson, we'll be exploring the concept of databases and how we hold information and how we make decisions about how we hold information has a big impact about how sustainable it's going to be. We'll start off by looking at a simple scenario here. Now, hopefully we're all comfortable with the scenario of being in something like a school or a college where you store the names of students, you store maybe their ages, some information about them, what subjects they take, maybe who teaches those subjects, and maybe the classroom it's in. And so we're holding all this information together in a single table or single file. And that's our first terminology we're going to learn here. So you see, we've got a list of different terminology we need to learn. And the first one is the idea of a flat file. Well, what is a flat file? Well, a flat file is a database that consists of a single file or table. So this is a flat file database. The flat file should be based around a single entity and its attributes. Now I want to take you a moment and have a look at there. I've not defined what an entity is at this stage, but have a look there and have a think for a moment. Do you think that is a single entity? So looking at it, we could quite clearly identify separate entities that exist within our table here. We've got student and their age, and when we think of an entity, we're thinking of a real-world object, person, or process. And a student and their age are actually really tightly coupled together. Indeed, you could say that this here is an entity of student. So we could have student as an entity that exists here. Well, I've said, and I've defined down here, that a flat file should only be based around a single entity. Well, is all the rest of it directly related to a student? And I would say no. The subject they're taking is going to be a separate entity from their particular name and age, as they'll be taking multiple different subjects, and at some point they won't take those subjects. These are separate processes. The teacher who's teaching a course, of course you could have multiple teachers teaching a course, so they're not necessarily directly related. However, I'm going to say that in this school, all teachers have their own classroom, so they actually are related to their classroom. You could argue easily that classroom or is another entity again. But I'm saying there's three separate entities in my flat file database. Is this a good implementation of a flat file? It is not a good implementation of a flat file, and it's leading to many of the issues you have when you combine multiple entities inside a table. Let's see what they are. One of them is data duplication. Do we see any places where data is duplicated? As you can see here, Bob is going to be recorded every single time. It's going to be reduplicated every time a new course is being added. And indeed, Mr. Foster or Mrs. Allen and their room and the subject, they're going to be recorded repeatedly. What's going to happen here is that, let's say at one point Bob becomes a different age, becomes 18, presumably doesn't get younger. And then if you update it here, well, what happens if you don't update it? You'd have to update it at every place that Bob is held. And that's going to lead to a concept called data inconsistency. Now, we won't actually come back to this for a while, but this is the big problem of having multiple entities in a single table, is that you will lead to data duplication, which will invariably lead to data inconsistency, which we will return to at a later point. Let's have a look then at some additional terminology that we need to look at. When we're looking in terms of a table, we can refer to each of these columns. These are fields. So student name, age, subject, each of those is considered a field. So how many fields does this table have? It has 5 fields. Thank you, Zahin. And each individual row going across is considered an individual record. How many records do I have right now? I have 3 records, okay? Now, that is different from the terminology of entity and attribute returned to. But in a table, each column is considered a field, and each row is considered each row is considered a record. So we can say a database record is a collection of fields about the same entity in a database, which we've already said that we've actually managed to mess up a little bit. The database record can be thought of as a row of information within a database table. So we can also think about fields can be discussed as the individual attributes. So if we all had this as a single entity, which we don't at this stage, but don't worry, we'll be getting there, we can consider student name, age, subject, teacher, classrooms. They're all attributes associated with an entity. So at some point we might identify that this is the student entity and its attributes are student name and age. But what is an entity? Well, an entity is a category of an object, person, event, or thing. And I described it earlier as a real-world object, person, or process. I mean, that's pretty much the same thing saying that, but I would say that this is your definition for what you want to use for an entity. And the question I was asking is, what entity can you identify? Which you kind of did earlier, but let's look again about how easily we can see what those entities are. So as discussed earlier, we could probably quite easily identify a bunch of different objects here, or entities here, I should say, my bad. We could say that the student name and the age, we could say, belongs to an entity that we might refer to as a student. We could say that subject could be an entity, which makes sense to call it subject. And then I'm packaging the teacher and their classroom because I'm saying the teacher exclusively teaches in the classroom that they're given and nobody else does, which probably is not true of a lot of places, but to make my life a little bit easier, I have said that. And so here we can see that I've actually broken it down into 3 separate entities. I've got students, I've got subject, and I've got teacher room. And let's come back to this concept here. A table in a database must consist of a single entity and its attribute. That was the rule, was it not? And did our flat file database originally, did it break that rule? It absolutely did, which led to the data duplication and data inconsistency. Now I've formed new tables, and in these new tables, I'm saying that they are individual entities of student, subject, and teacher room, and they have attributes that only relate to that entity. Like I say, you could make an argument about a classroom that's not directly related to the teacher. I get that. Typically also you'd be having a lot more attributes than this, but I don't want to just, pile in too much stuff into this little presentation. Okay. Essentially, what now I've created is 3 separated flat file tables, flat files, and great. They all have individual. They all have individual entities. And we have some issues. What are some of our issues? Well, we have a couple of problems. One is we still have duplicate data, do we not? It currently looks like I'm storing 2 different students called Bob. Now, because we saw what the original was, did I have 2 students called Bob? No. Well, I guess we don't know for sure, but I'm saying we don't. They were just the same Bob, but subscribed to different courses. And I'm also saying here, we got these 3 floating around tables, flat files. How do we actually connect them, relate them to each other? Thank you for the feedback from the class. We've identified that duplication is bad. I agree with that. And that we also need to somehow link them, which you're very much correct about. So the duplicate data, do we need to hold it multiple times anymore? No. So we should remove duplicate data. Bob needs to be held once. Mr. Foster, as important whoever that guy is only needs to be held once. Okay, as the subjects need to be held once. So that's a fix we can do. But linking it's going to take a little bit of thinking about how we're going to achieve that. So, as you can see on the student one, I've now done part of the fix. Part of the fix is I've now removed the duplicate data, and I've actually extended it a little bit. I've extended it by adding an additional field. You consider attribute for it. What is the additional field I've added in? So it was just name, and now it's first name and surname. Technically, all databases, to hold something called atomicity, where data should be broken down as simple as possible, should always be broken into first name and surname. A bit like when you put in your address and you do it on multiple lines, that's breaking up the data into the simplest form. Anyway, this is doing this to learn a little bit more terminology about primary key and secondary key. So as you have to quickly write that down and have a think about it, I want you to have a look at that student table and decide what is going to be the primary key. So as we're looking for a unique identifier, we had an example from somebody in the class to say we could use somebody's name to identify them. Now, if we use their first name as a primary key, as a unique identifier, the issue is going to be is there are many Bobs in the world, as there are many Mo's in the world. So unfortunately, it won't help us uniquely identify it. Now, another choice you could make is combining fields together. And we'll have a look at that later, and that's what's called a composite key, when you use the mixture of different fields together. Now, could we have somebody who has the first name Bob and the surname Smith and more than one of those? Yeah, that is also kind of a problem then, unfortunately. And being as it's a school, the actual age of the person is not going to be that helpful either, because most people in this college are going to be 17 or 18 or perhaps 16. Now, a lot of schools do decide that, and in fact, if you're in a school or college, you might think about your email address you've been given, right? And it probably is a composite of your first name, your surname, and maybe something about your year on entry. And they're rolling the dice a little bit, and that happened once at our school. A few years back, we used to always use the first letter of their first name, their surname, and year of entry. And unfortunately, two people had identical things for that, and actually merged and created the same account. So they were both pointing at the same account, and they kept on resetting their password every single week, which was fun. So we could do that. We could create a composite key, but we run a little bit of a risk. And the little bit of the risk is this, is that you could actually have two people with the same combination. We could also do this. This is another choice, is we could introduce a new field, right? And the easiest way to do something uniquely is to just think, well, we can just start with a number and move way up. So maybe we could call this something like, I don't know, Stew ID. And then we could say this Bob, he's Stew 1. Mo is Stew 2. I don't know. Alice is Stew 3. And onwards and onwards. And the idea is that every time you have a new student, it increments it. Now, you might have encountered this kind of thing with your student number, whether you've been issued it. Now, of course, your student number probably isn't unique to you, but you combine it with your center number, and the combination of your center number and your student number, the composite of those two things, is unique to you. Or a national insurance number, which will be unique to you, or a plate has to be unique as well, right? Because otherwise it identifies more than one car. These are things that are used as primary keys. So what is a primary key? Well, a primary key, as we discussed, is a unique identifier. And now we have introduced into the student table, really ugly with my best handwriting, believe it or not, a new primary key, which is a unique identifier. Okay. Does subject have a primary key? Currently it doesn't. Philosophically, you could say, actually, does it really matter? Because there's not going to be multiple computer science. No, it could be an issue. You'd have computer science OCR, computer science AQA, could be an issue that way. And then teachers, additionally, you could have teachers with the same name. So we're going to have to introduce some form of primary key for them, for these other tables as well. But I wanted to introduce this one as well. So we've got a primary key is the unique identifier. So how do I identify Mo? Mo is STU2. How do you identify yourself in an exam? You don't do it by your name, you do it by your student number. That's how you uniquely identify you. What about a secondary key? Well, a secondary key is not about uniquely identifying. Often what you need to do in a database, and we've done a lot on searching and sorting, have we not? Is you want to actually go through a database and find a particular record. Now, is it faster to search through a unsorted or sorted list? Far faster to sort through a sorted list. So a secondary key allows a database to be searched quickly, okay, which means that So, and to be searched quickly, we need it to be sorted. Now, do you think I could sort by primary key, but if I'm looking for an individual student, do you think I'm searching by, do you think I know your student ID number? I have no idea what it is, right? Okay. What, if I'm searching for you, will I search for, do you think? Yeah, but that's not the question. Now, what will I search for? The name. Which one? Surname most of the time, right? I probably will do, yeah? So which is my secondary key here? Probably surname. What will that mean? As I'm adding new items into here, what will it mean? What's the implication for surname if it's my secondary key? It's going to be, no, what do we need it to be to how it to be searched quickly? Sorted. So it will be sorted and potentially indexed. By indexed, it might say, what number does S start at? Which number does D start at? Which number does whatever start? Now, that has not solved one of the two problems. One of the problems we had was duplicate data. Now, you can see here, I've actually removed the duplicate data in all my tables here. And you see I've introduced sub-ID here. Sub-ID is my... what is sub-ID? It's my primary key. So I can uniquely identify these. For teacher room, does it have a new primary key? Does it have a primary key here? So you think that's a foreign key? It's not a foreign key. That there is the primary key for teacher record. Okay. My second problem I have, though, is that they are still just floating around in the air, right? Somebody from the audience said we need to link them in some way, and I completely agree with you. Before they were linked, because they were all in one big file, yes, in one big table, and we could see which one related to each other, because you could just go across the row off the record and you could see it. Unfortunately, it led to duplicate data because we have multiple entities in that table. Now we need to figure out a way of linking them. Well, we have a primary key, which we discussed before, which we see here. And the primary key is the, excuse the phrase here, the key to linking these entities together, because they uniquely establish which each of these are. You basically use the primary key to link it to another table by moving a copy of it into another table. When you move from one place to another, you are foreign from that place. So it's a foreign key. So when we move a primary key from a table into another table, it's referred to as a foreign key, and that establishes the link between two different places. Have I put a foreign key, do you see anywhere where I put a primary key into another table it doesn't belong to? Okay. I don't know how you're seeing that. So somebody from the audience has said that they can see a primary key from a table put into another table, and it suggested that subject has it. Now, where do you see the foreign key in subject? What? You didn't see the letters properly? Okay. Do we see a primary key from one table in another table anywhere? No. Hence, have I got a single foreign key at the moment? No. Hence, meaning, do I have any links? No. So they are still floating around in the air. Can you please write down the definition for foreign key? And then we're going to have to think about how the hell we're going to do that. Now, what you might think then is what we could do is we could move StuID in here. So we could have StuID exist as an additional field in subject. Now, StuID is here. Was Bob taking computer science? Yeah. So we can write down Stu1. Do you see now it's related? You're saying we can see that Bob Smith is taking computer science. Yeah? How about, did he take business, Bob Smith? I think he did, right? Did Mo take computer science? How do I put Mo in here? I'm going to have to maybe have StuID 2 for the second student who wants to take it. Or I can go here and go sub1 Komsky Stu2. Are either of these solutions, do they seem suitable to you? This one is really unsuitable because are we duplicating data? Yes, we are. Is sub1 a unique identifier now? No, because it's saying which one of these two things, so we can't do that. By going this way and just adding in additional fields, do we know how many additional fields we need for student ID? No. This is planting seeds for the future. What we've just created is what's called a many-to-many relationship, because many students can take many courses. And that leads to this issue. A lot of people struggle to visualize this. So just you see, like, I could add in loads of student IDs here, and then when you think about it, if I wanted to link it the other way around, if I wanted to put subject ID, so if I move subject ID into this table, what was that called? Foreign key. How many sub IDs do I need to put in for Bob? Maybe 1, 2, 3, 4, we don't know. Do you see that neither of these are going to give us a very suitable solution? You see that? Yes, in a meaningful way. But we still need to move the primary key into another table for it to work. We have what is called a conundrum right now. We need to have our big brain thinking all connected up right now. Excellent answer and good thinking, good big brain thinking. The solution to this is to actually introduce a new table. We can't just move the primary keys into one of the existing tables as a foreign key without creating either this problem or potentially this problem, the data duplication or additional entities. The new solution, or the solution for that, is to introduce an entirely new entity, maybe called registration. And registration will take the primary keys from each of these tables to form a link, but each of those records will be unique. So the student who takes a course with a particular teacher will be a unique record. In fact, here's one I prepared earlier. We've got the registration table, and you see, in registration, where does StudID come from? From the student entity. In the student entity, StudID is a what? What do we call it? A... But over here, it doesn't come from there. It's a... Sub-ID is the... So, we actually talked about this earlier. We talked about the idea of perhaps using multiple attributes or fields to form a key. And we talked about that potentially doing that with the fields in the student table. We said we could use their first name, their surname, and their age, and combine that to form a key. But we said, do you know what? That could be risky, because we could have two students with the first name and surname and the same age. So let's not do that. Let's introduce a new field for student called StudID as their primary key. Now, I'm suggesting that for registration, that we can quite safely use the combination of all these three things as a composite key. Why am I saying that? Well, let's think about how we're going to be used. So this registration table, I'm now going to use it to create my link. But let's actually go through the motions. I think it'll make it easier to understand. So if I put Stu1, who have I just picked up? If Bob wants to do computer science, what will they now have to write down? And then TR1. Do you see that's going to be unique? How can Bob do computer science with Mr. Foster more than once? Because each of those is a unique record. If I have Mo, I'll write down Stu2. And then he wants to take computer science as well, which is also taken by Mr. Foster. Do you see, each of these is going to be unique. At some point in the future, we've got Stu96 taking sub 7, taking TR8, or taking my TR8. This is going to be a big old table, isn't it? Yes, but the combination of each of these three foreign keys, do you see that's going to be unique every time? So this time I feel safe in using the combination of these, because have I introduced a primary key here? What's the primary key for registration? Well, exactly. I haven't got a primary key, have I? Do I? I don't. Now I could introduce a new field here called regID. regID1, regID2, regID3, etc. Or I could just say, I will form a primary key through the composite of these three values. So stu1, sub1, tr1 is a unique identifier. And it is, right? Because they're never going to do it twice. So in this case, I've actually made use of a composite key. So a composite primary key, sometimes 2 or even more, in this case 3 attributes, are needed to uniquely define a record. So I've done it here. So I think it's a good question, and let's do it. So question was, why can't we merge subject and teachers together? Now, do you have any of your subjects taught by more than one teacher? Spanish? Finance. So who teaches finance? So it would be sub 3 finance, right? That would be fine. And then teacher, Mr. Elliott. Sub 3 finance and teacher, who's the other one? Miss Gardner. Miss Gardner. What have I just had? So let's say that again. Sub 3 finance, and if I put the teacher in here as well, Mr. Elliott. Sub 3 finance, Mrs. Gardner or Miss Gardner. What have I just had to do? Duplicate. And also I put sub 3 down twice, so it's not unique. Now, alternatively, you could say, oh, that's sub 3, sub 4. But do you see that actually, not only that, but Mr. Elliott might teach multiple courses. He might teach business as well. So actually, Mr. Foster might teach ICT. No, he might, right? Okay. So they actually aren't that as related as you think you're going to be. Now, ultimately, you could say arguably that this is a risk you want here. The room, a teacher could easily be teaching in multiple rooms. So ultimately, that probably should be another entity again as well. And I left it in there to have that discussion. And actually, it might not be linked to the registration table. You could have a separate table over here called teacher room, and teacher and their room could be linked. And that's why I had the conversation that arguably room, and I think if I was doing this as a real database, for sure if I was doing this for a real database, room would be its own entity with its own table. And ultimately, you probably link it from the teacher table directly to the room table because they are paired together, but they could be teaching in different places. Okay, so the next thing we're looking at is entity relationship diagrams. We've established that we've got these multiple entities of student, registration, subject, and teacher room. And we've talked about how we could populate the registration entity or table to show how it links together. What we need to do also is have what's called a entity relationship diagram to show how we can link these separate things together. Now, these tables, you see, they're basically it's the entity descriptor for this. What does that remind you of? You ever seen anything like that before? A class diagram, absolutely. Class identifier, attributes. What's it got missing? Methods. Now, of course, records don't have methods, so this works for us, right? It's the entity identifier and the attributes of said identity. An entity relationship diagram is a graphical way of representing the relationships between different entities. And so we could show how these relate to each other, and we're going to review that on the next slide because I talked about there being a problem of many-to-many. I don't know if you remember, because I talked about that being an issue of, well, how do you actually represent that? Do you have multiple columns for each of the students? Did you have multiple additional duplicate data in the rows? But there are 3 major relationships, and we'll have a look at them. Oh, sorry. I'm skipping ahead a little bit. I was talking about different ways of holding that information. So these are, where do we see these before? These were on the last slide, weren't they, when we looked at ways of representing the data description. Now, it doesn't say what the values are. It just says what the entity's attributes and name is. This is a way of actually writing down the descriptions for each of the entities. In bold, we have the name identifier of the entity, absolutely. And then we have each of these are the attributes, and underlined is the primary key. Now here they have different ways of doing it. Sometimes they do it in italics to show that it's a foreign key. But because the problem is I'm also using it for the composite key, so I'm underlining all 3 to show it's composite. But you see, that's a way that you can be asked to write that down, and you can see that it actually describes the entity. Does it show the values? No. On the next slide, we're going to look at the different relationships entities can have with each other. with some fun examples. So these are entities. A husband and a wife, a school and a pupil, an actor and a film are all examples of entities we can imagine, right? With whatever attributes they could have associated. An actor could have presumably a name, I don't know, age, stuff like that. There are three possible ways in which two entities can be related. So it's one-to-one. So one entity has a relationship with one entity over here. So one husband has one wife in this concept. I'll give you an example. You tell me whether this is one-to-one.
Oh, sir, a child can only have one dad, like one biological dad.
Okay, so one dad has one child. What happens if they have more than one child?
There's a house, and there's going to be the...
One too many. What happens if... So, in non-polygamy based legal systems, when husband has one wife, you could say one owner has a dog, but actually an owner could have many dogs. And a dog could have multiple owners as well. Now, legally, in terms of registering it, I think you only have one owner. There we go. But the owner still might legally have multiple dogs. The point I'm making is that one-to-one relationships are actually not that common. Most of the time, and actually if you think about it, a lot of one-to-one relationships, if one of these things has one of the other things, like I said essentially that there's a one-to-one relationship between teachers and their classrooms. And so a shorthand for that, if I'm saying there's a one-to-one, you can just stick it in the same table then, right? Because there's no duplicate, is there? So generally, you won't see many one-to-one relationships. I'm not saying they don't happen, but you won't see many of them. You could say, oh no, that's not even a very good example. I'm going to say one person can have one credit card because they have multiple credit cards. I mean, it's actually excellent example from the audience, from the class. One person has one birth certificate. I mean, I have duplicate copies of the same thing, but it's one birth certificate that from the original. So that could be a one-to-one. One-to-many. So we're saying a mother with a child. So one mother may have multiple children. Okay, now that doesn't exclude they could have no children or one child, but what you need to do is catch the opportunity that it could be more than one. So it could be for many events, like we talk about students taking courses. We're saying on average students take multiple courses, but potentially it could be sometimes a one course. But you have to catch the situation where it actually is multiple. A school and pupil, so a school has multiple pupils. And then we talked about many-to-many relationships. Now, we looked at a many-to-many relationship earlier. What was the many-to-many relationship we almost made? We did it by linking students directly to subjects. Now, the problem is, can a student take multiple subjects? And can each of the subjects be taken by multiple students? Hence, we have many-to-many. And although it's not established here, many-to-many relationships are a serious issue that we need to get around. Now, if you look here, there's actually a way of drawing it. One-to-one is just a line between two different entities. One-to-many, one is like this. A many is like this web thing. This web thing here, that indicates that it's many. And many-to-many is that the web thing's on both sides. And of course, you could have many-to-one as well, couldn't you? And now, what I'd like you to do is try and draw the relationships on this entity. We've got student, we've got registration, we've got teacher room and subject. The links will go from the primary key to the foreign key. So the primary key was in student. Where do we put that? What table do we place that key in? So the link will be this way, won't it? Yeah? Same from subject got placed in registration. I want you to now think about how you're going to draw those relationships. Have a go. One of the tools that you may find useful to consider, whether it's one-to-one, one-to-many, many-to-one, many-to-many, is consider an individual item or an individual a person inside this table. So we had student and we had both Bob and Mo. Bob was Stu 1, Mo was Stu 2, I believe. And they appeared how many times in the student table? They appeared once. However, the student could actually appear, Stu 1 could appear multiple times over here because they could register for multiple courses. So you would say that the student has a one-to-many relationship with registration. So we've got a one-to-many relationship between student and registration, and using the tool we just discussed, we can have a little think about how the relationship between subject and registration is going to be. Because bear in mind, it must be subject to registration because it was the primary key from subject, sub-ID, got put into registration, right? That's the way it worked. So we can think about how many times a particular subject, like computer science, showed up in this table versus how many times it could show up in registration. So how many times will computer science show up in subject? Once. However, every single time a student registers to do computer science, it will appear multiple times over here. So then it will be one-to-many relationship that way. And finally, have a think about teachers. So the teachers were Mr. Foster and Mrs. Allen, or Miss Allen, I believe. I can't remember which way I wrote it out. And they are appearing with their room as well, actually, inside that table. However, how many times would they appear in the registration table? So we've got the same situation here of one-to-many. So we did our entity relationship diagram using just the name of the entities. What you can also do is do the same thing, but linking the specific field to entity. So in student, what is the field or the attribute we're using to link? Yes? Student ID, because that, or Stu ID, yeah, is the name of our primary key. And then in registration, it's the, so we can link, we create a direct link between these two. Oops. Anything else do you think I need to do here? What else do you think I need to demonstrate along with the... There you go. So you can also look at doing these kind of relationships here. It could be another way of representing the same thing. In fact, I've really kind of stuffed myself here because you can see that with the teacher ID, I'm going to have to jump over it or something. So in here, we have the many-to-many relationship we discussed much earlier between subjects and students, because each student can take multiple subjects, but each of those subjects is taken by multiple students. And if you remembered, why was this a problem? Well, because what we'd have to do is add in loads of columns for the number of subjects the student's going to do, or alternatively, if it was for subjects, you'd have to put in columns for every single student. Now, can I here identify how many different student IDs I need to stick in? No, right? You can't do that. And that would be a really inelegant way of doing it. Or alternatively, by having duplicate data, also a bad idea. So many-to-many relationships, as discussed earlier, are a really big problem. And I'm saying many-to-many relationships are not allowed, need to be burnt in a fire, because they invalidate, well, they invalidate a normalization, something which we'll learn about later, about how we form databases. It's a tool for forming them. But you can see in terms of practically that it's going to cause these problems that we can see on our right. What is our solution? Well, what was our solution for linking tables earlier? Our solution, like we did last time, is to form a new table. So what we can do for this many-to-many relationship is we form a new table in between the two of them, and we can create a bridging or linking table. So I formed a new table called student subject by just taking, I mean, you could call it whatever you like, but I've taken the two names. This is a classic way that people do it, is you just take the entities of the name of the other two entities and merge them together. What do I need to put in there? Well, to create a link between tables, what do I need to take from one table to put into the other? The two primary keys, and put them into this one to create your foreign key. So I'm going to do that. So what we've done is we've moved the student ID and the sub ID from the two tables, the primary keys, into here, forming a foreign key. What's the relationship between student ID in a student and student ID in student subject? What's the relationship going to be? One to many. I completely agree with you. Because each student will appear once in here, but multiple times in here. What about sub ID in subject to sub ID in student subject? There you go. Do I have a primary key in my student subject table? No. However, based on what you learned earlier, what could I use? A composite key. The composite of student ID and sub ID is, by definition, going to be unique. So that I can use there. And there, what have I just done? What problem did I just solve? To solve a many-to-many relationship, form bridging table and connection in between.